What would you do if a core part of your job just changed? Not over years, but literally overnight. Well, that's exactly what AI researcher Andrej Karpathy says happened to him. He actually calls it an AI psychosis, and it signals this massive shift in how we build things, what he's calling the end of coding as we've known it. All right, so here's what we're going to cover. First, we'll unpack that end of coding idea. Then we'll get into why your own skill is suddenly the new limit. After that, you'll meet the Claw agent, the tool making all this happen. Then we'll see how AI can research itself. And finally, we'll talk about the jagged frontier, the weird and uneven power of these new systems.
So this AI psychosis, what is that? Well, it's this feeling of being in a state of constant, low-grade shock at what's suddenly possible for one person to do. For Karpathy, this wasn't just some abstract idea. It completely changed his day-to-day reality at work.
And man, this quote just nails it. The job isn't about painstakingly typing out commands anymore. It's about figuring out what you want, your intent, your will, and then communicating that to your AI agents. The verb isn't to code anymore, it's to direct.
And get this wasn't some slow, gradual shift. Karpathy points to a specific moment, around last December, where the whole thing just flipped. One day, you're spending 80% of your time coding. The next, you're spending 80% of your time delegating. The entire workflow, stable for decades, just got turned on its head.
Okay, so if you're not limited by how fast you can type code anymore, what is the limit? This is where it gets really interesting and, frankly, a little intimidating. The bottleneck isn't the machine anymore. It's us. It's the human.
Just look at this shift. The old limits were physical things, right? How fast you could type, how much computing power you had access to. But now the bottleneck is your own ingenuity, your ability to think clearly and direct these agents effectively. It's all about your skill.
And that leads to this huge psychological change. When something breaks, your first thought isn't, oh, the tool must be broken. Your first thought is, I must have given it a bad instruction. It's a skill issue, as the gamers say. It's a ton of pressure, yeah, but it's also where all the power now lies.
So let's see what this looks like in the real world, because we're not talking about a better spell check or autocomplete here. Not even close. We're talking about a completely new type of tool that Karpathy calls a claw agent.
The key thing to get here is that this isn't a one-and-done command. You don't just ask it a question and get an answer. A claw agent is persistent. It sticks around. It remembers what you were doing yesterday. It just keeps working on a problem, looping through solutions on its own. It's like having a tireless intern who never sleeps.
And this story is the perfect example. He's got this agent he nicknamed Dobby the Elf, right? And he gives it a super high-level goal: find my Sonos speakers. And you're not going to believe this. After just 3 prompts, the agent scans his network, figures out how the speakers work all by itself, and bam, music starts playing. Now, Dobby runs his entire house, lights, heat, you name it, replacing 6 different apps.
Okay, running a smart home is one thing. That's really cool. But what happens when you turn these powerful tools inward? What if you use these agents not just to play music, but to actually do the science for you?
This is the core idea behind his concept of auto-research. It's the logical conclusion to the whole skill issue thing. If the human is the one slowing things down, well, the fastest way to make progress is to set up a system where the human isn't even in the loop.
And the results from this were just mind-blowing. So you've got Karpathy, an expert with 20 years of experience, manually tuning a model as best he can. Then, he just lets his auto-research agent take a shot at the same problem overnight. He comes back in the morning, and the agent had found better, more efficient settings that he, the expert, had completely overlooked.
Now, you don't have to be a machine learning expert to get why this is so huge. The agent found these tiny, super complex interactions between settings, stuff that is just incredibly difficult for a human brain to juggle all at once. It could systematically check every possibility and find optimizations that were basically invisible to a human.
But look, it's not all a perfect, smooth ride into the future. Karpathy is really clear about this. The intelligence of these agents is incredibly powerful, yes, but it's also really weird and uneven. He calls it the jagged frontier.
This is the total paradox of working with these things. One minute, you feel like you're working alongside a brilliant PhD. The next minute, it'll make a mistake that a 10-year-old wouldn't. This jaggedness is one of the biggest challenges and, honestly, one of the strangest things about AI right now.
So here's a super simple, non-technical way to see this jaggedness for yourself. What happens when you ask one of these top-tier models for something that isn't easily measured? Something like, say, a joke.
Odds are you are going to get this exact joke. It's pretty much the default punchline for today's most powerful AIs. But the joke itself, that's not the interesting part.
The interesting part is that this joke hasn't changed in years. So while the AI's ability to code has gone stratospheric, its sense of humor is stuck in the past. And why? Well, because humor is soft. You can't really test if a joke is good or not, so it's not being optimized. It's just left behind.
And all of this brings us back to one central point. We are entering what Karpathy calls a loopy era, driven by these autonomous agents and limited only by our own skill. So that leaves us with the most important question of all. What are the skills that will matter now? It looks like the future belongs to the people who can best direct these brilliant, powerful, and deeply weird new tools.